Okay. This week we will talk about the convolutional neural network. Okay? Introduction to AI and specific topic of what convolutional neural network. Okay, so in the first place we suppose that we have data distribution like, for example, x1, x2, x3, blah 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 blah, and xn. Okay, and so we have the n-dimensional data in here, right? And so how many features can be included in this data? The n feature, which means that we have the n axis on the what? On the hyperplane or the 3D dimension. Okay, and so we can write the data set like 1, 1, 10, blah blah blah, and so 2, 2, 1, blah blah blah, and 3, 3, 3, 3, 3, 3, 3, 3, and 3, 3. And in the fourth place, in the fifth place, we have the 100, 99, 98, 97, and blah blah blah. We have at the last data 9. Okay, and the other data 4, 4, 4, and 1, 2, 3, 100, 200, 1, 2.2, 3.3, and blah blah blah. Okay, this is what? This is our input data. Okay, but in order to analyze the data, or when we look at data like this one, and so we can easily set that we have the same pattern in here. We can observe that because if we want to analyze this data, and then we can say that the whole data in the third and fourth column are the same or close to each other. Okay, and beside of that, we have also a one pattern in here like this one. And so at each step for the given data, we have the one decrease values of the what? The x1, x2, x3, and xn. Okay, and after that, if we want to use the whole data, we can produce the what? The y, or the output values. Okay, by using these terms. And so we can say that this is the always same pattern, and this is always decrease. Okay, and so if we are using this standard NN application, we cannot bind this whole data into one form, because if we have this pattern, and so this is all the what? The one-dimensional data in here. Okay, this is 1D, this is 1D, and this is 1D, and so we have the what? The horizontal pattern or the horizontal distribution, and so we can link the horizontal data at each x1, x2, and x3, but we cannot bind this data in a vertical way, because each data represents the what? The different dimensions or the different axes on the what? On 3D space. And so what happens if we want to use the what? The both the horizontal and vertical data? Because if we have 1, 2, 3, and 3, 100, and so this is always a random data. This is always random. This is always random, random, random. In the what? In the horizontal way. But if we look at the vertical way, or the vertical distribution of this data, we can catch the pattern. Okay? So, This are the features for the any AI application. Okay, and so how can we use this horizontal and vertical data? We can build the two-dimensional data distribution, which we call it the what in machine learning literature grid data. Okay, this is called the grid data. And so our conclusion is that we need to analyze the training data set or the input in both directions, right? And we will look at to the what to find a similar pattern. Okay? And so it's not enough to use the one-dimensional data, even if we have the n times or the n different input in here, because we can build the horizontal similar patterns, but in a vertical way we cannot do that. Okay? For example, if we have this information in here like this one, and so in biomedical signals we can use the ECG to what? To build the classification problem. For example, when I analyze this data, and then I can assign the what to some conditions or the illness or the unhealthy conditions. Okay? Or we can measure the what, the contractility or the time period of the heart by looking at this one. But in this data, in order to understand the, for example, beginning of the contraction, we should utilize this data as a complete pattern. But one point is not enough to decide to the what this is the beginning of the contraction phase or the relaxation phase in the ECG signal. Okay? For example, in the biomedical literature, this is the what, this is the contraction phase, and so this is the what, it's the relaxation phase. But, for example, this is equal to the 1, and so this is also equal to the 1. How can I decide that the correct phase of this term? And so, in order to point the true or the healthy or unhealthy conditions in this signal, and so we need to obtain the some window-based approach. The data with the what, with the relation of the next values or the previous values. Okay? This is called the what? Time-dependent data. Okay? Time-dependent. For example, in the mechatronic applications, every application is a time-dependent application because we have the integrator and the differentiation operation in our systems. Okay? For example, mass spring damper system has a what? A time-dependent system. Okay? So, if we want to analyze this term, we should create the T like this one, I and I plus window length. Okay? And also, we should maybe add some another feature like this one. This is the what? This is the, for example, the flow rate of the heart. Okay? And so, how can I combine all this data into one form? And so we can collect, or we can assign the x1 in here like this one and x2 like this one, and so we can easily fit to the what? To the standard multi-layer perceptron application. And so we may have the correct positions or the correct determination of the what, some cardiovascular conditions. We can classify it, but it's not appropriate for the what for this task, because this data is a window length in here, and so in the standard multi-layer application, even if we can use the recurrent application, And so we cannot easily analyze the time series data. And so we need to build the what? We need to build the some window-based example or the data distribution. Okay? This is the horizontal one. And so, especially for these two signal, if we want to create the what, the horizontal and the vertical axis similar pattern, if we want to bind this data into one form, we can also use the what if we have this data. And so we may have, for example, taking the square form is here, like this one. Assume that this is the GT, and so we can use the GT square form in here. In order to what? In order to enrich your data distribution in here. Or we may have take the absolute values of the GT. Okay? Or we can use the what? The Fourier transform of GT. Or we can take the what? The wavelet transform of GT. In order to what? In order to obtain the not only the time series characteristic, but also the what? The frequency characteristics into the one form. Okay? This is the what? This is the enrichment of the what? Our data. But just remember that standard ANN applications just looking at the what? The horizontal and point by point determination of your signals. But if we want to add the what to the application, and so we should create the what? The some 2D dimension or the some matrix. Okay? And so it's our conclusion is that we need to firstly 2D data distribution. Okay? And so what is this? And so the vertical and the horizontal dimension can be linked to each other. Okay? Because we can analyze this data in this direction and also in this direction. And so if you want to build this form, and then we may have the what? The some image or 2D matrix in here, like this one. And so if we have the 2D matrix, and then we have the data in the horizontal way, the column values and the row values. But if you look at this pattern at one time, and then we can say that this data may be not meaningful in the horizontal way, but the vertical way gets a lot of things about the classification or the conditions. Okay? This is why we need to increase or enrich your data into the 2D application. Okay?
Looking to each of them at the same time makes meaning, but if we look to it vertical or horizontal, we won't take meaning.
Yes, because just like this example, if only I look at the data on these terms, like this one, this is the one and this is the one, but in one phase this is the contraction, the other phase is the what? Relaxation. But it's the same way. But if I add this pattern in here, like this one, and so this is the what? The beginning of the flow rate, and so this is, for example, just like this one, and so this flow rate is diminished in here. And so I can classify the whole data by using this notion. And so if I collect the whole data into one form, and this creates to the what? The 2D dimension, or the matrix, which we call it what? The picture or the image in your applications. Okay? And so another example is that, for example, we have the what? Some cat in here, like this one. This cat, okay? This not look like cat, but this cat, okay? And so, if I look at the horizontal data like this one, age, and this is the vertical data. How can I identify this is cat? By looking one way, one direction. I cannot. Why? Yes, because if you want to identify any cats, maybe we need to look at your head, like this one, okay? This is meaningful, not the one-dimensional data in here, or not the one-dimensional in the vertical direction. And so, what is the meaningful data? Meaningful data is that this is the section of the what? Red part, okay? Okay. And so, the convolutional neural network is mainly utilized to what? To build the relation of the tensor between or with higher dimension. But ANN cannot. Okay? What is the tensor? Do you know? Tensor means that if you have any data or any distribution in 3 or 2 dimension, this is called the tensor. But in the 5th dimension, if you suppose that you have 5 dimension or 5 matrix form, and so this is called the tensor. And tensor also means that each variable are bind or are dependent to the other variable. For example, you have the x-axis, y-axis, and z-axis, okay? And so x and y is related to each other, and then we can call it its tensor, okay? This is the basic definition of the tensor. And so any image can be called a tensor, okay? And so what is CNN right now? Convolutional neural network. And so in the previous week we have talked about the what? The neural network. Okay? Just remember that. This is the neural network. The neural network is the what? The simple multi-layer perceptron, or the many perceptron can build to the what? This neural network application for a given what? Any training data or the test data. And so we can build the regression model or the classification model by training to the what? To this network with the what? Training input and the outputs, okay? The target values. And so what is convolution? This is the convolutional neural network means that this is creates to the what? 2D or more dimensional relation with your data, just like this image, okay? Or we can build the 1D, one-dimensional convolutional neural network with specific filters in order to what? In order to build your model to represent the more data than the previous one or the original input one, okay? This is the definition of the what? The convolutional neural network. Convolution means that in your lesson, signal and system, and so what's the convolution? Convolution means that the similarity rate of 2 functions or 2 pictures. For example, if I have two pens in here, like this one. This is pen, this is also pen, right? Okay. What's the similarity rate of this pen? These pens? In probability. 13 is not 30%, 80% maybe, because it have the circular pattern in here, and so it's black, and so we can write this pattern, and so this is the similarity rate of your what? Nomination. And so in math this is called convolution. And so we can each this pattern process the whole pattern and compare this pattern. How much similarity is obtained by using these terms. And so if we have the two function ft or gt, and so we can multiply in one integral, and so this is the similarity rate of your what? The pens. Okay? This is convolution. The similarity rate of the what? The two image. And so in person or just we can decide the what? This is pen and this is also pen. And so we convolve in real life to what? This pattern and this one. Okay? Because this is the pen. We know that. And so we can also know that this is maybe pen. Okay? This is convolution. We can decide any data in here like this one. And so this feature is given in this data. Okay? And so if neural network gaining to this similarity rate ability, and then we can call it to the what? The convolutional neural network. And so this neural network is trained in a supervised way. But this convolution is an unsupervised way or supervised way. Okay? And so this is built to the what? The semi-supervised learning in each phase. But in our application, we train also the convolution layer. Okay? Any question? You get it? You understand the difference between the standard neural network and the convolutional neural network, right? Standard neural networks only take the values of the what? The horizontal data in this picture. But convolutional neural network gets the more dimension to be analyzed in your structure. Okay? And also we can what? We can build the model in a supervised or the unsupervised manner by using these terms. Okay? So if we have this definition, and so we can define the layers of the convolutional objects. Okay? In standard neural network application, we have the input layer, the output layer, and also we have the hidden layer, right? In the previous week, we have talked about it. Okay? But in the CNN applications, we have the 9 different layers to be used in this application or in this kind of neural networks. Okay? So in the first place, we need to give the input layer. Input layer, like the standard neural network application, it's just like this one. This is the raw input data. Okay? For example, standard image or the signals. Okay? So typically this is the 2D matrix or the image. Okay? This is the first layer. And so in order to build the CNN network, and so we need to define the input layer. Okay? In the second place, we have the convolutional layer. In the convolutional layer, we have the learnable filters. To the image, which means that if we have convolve the image with the one filter or predefined filter, and then we can obtain the new pictures. with different features. Okay, for example, the age detection. How can we obtain the age detection from the image? And so we can use some specific matrix to be multiplied or the convolved with this image, and so we can produce the age more observable. Okay, this layer contains this kind of filters, the specified number. But in convolutional neural network, we can learn this filter in order to what? In order to increase your classification performance or the regression performance. Okay? And in this learnable filters, we have the kernel function. Okay? And so this kernel function is trained by backpropagation rule and convolved with the image to what? To different feature map. Okay? And so if I apply the sum filter in convolutional layer, and so our input data to what? Transfer to another one, another feature, and this feature maybe increase your performance to classify the object or the regress, or fit the any line or data. Okay? I will explain each layer one by one. Okay? And so after that, we maybe utilize the activation layer. Activation layer means that it's like just creating the nonlinearity or the hard nonlinearity. Okay? And this is helping to analyze the complex nonlinear patterns. For example, we can limit the outputs to the 0 to 1 in each layer after the convolution one. Okay? And so this is the output of this convolutional layer, but the output of this activation layer is also a different map from from the convolutional layer. Okay? And then we can build the pooling layer. The pooling layer is mainly utilized to downsampling your data, which is coming from the activation layer one. Okay? The activation layer output is fed into the pooling layer. Okay? And then we can downsampling all the data, because maybe if you have the 4000 times 4000 matrix in here, and so we may have the many features, a million features, but the only one pattern may be meaningful. And so this pooling layer is utilized to this data, and this is also reducing the overfitting. Okay? It suppresses the whole noise and data from this one. Okay? So after that, in order to build your CNN architecture, we can give the fully connected layer. And so in the fully connected layer, we have the standard ANN application. Okay? It's the standard ANN, multi-layer perceptron. Okay? Fully connected layer means that standard ANN application. And so this layer classify, or we can make the regression or fitting some data in here. Okay? We have the sigmoid or any ReLU function in here to be used to train your network by using the standard a stochastic gradient descent or the Adam optimizer by using the standard rules of the what? Neural networks. Okay? At the end of this code, we build the output layer. Okay? The output layer means that we can decide the data to what? To possess the any class or the any fitting line. Okay? We can assign the what? This class is the illness or the unhealthy condition or the healthy condition, or this is red or this is white. And so in the output layer we have produced the final prediction. Okay? And so we can use the linear neuron or the softmax neuron in here. Okay? Regression or the classification can be accomplished by using this output layer. Okay? Besides that, apart from that, we have also a normalization layer. Can be used in what? In standard CNN application. This is called always the batch normalization. What's the meaning of batch normalization? Batch normalization means that if you have data or the many data distributed to the what? To, for example, around the 40, and one data is 1, and the one data is the 10. And so we have the some data 1, 40, and 0.001. Okay? This is the distribution of the what? The convolution 1 solution, convolution 2 solution, and convolution 3 solution. And so this is seen to the what? To the unmeaningful data. Right? Because this like some noise in here. The bigger part of this data is the 40. Okay? This total dominant data. And so this batch normalization normalize the whole data with the what? With the mean and standard deviation of the input values. And then we can produce the what? To each data with the same priority level. Okay? And then if I use the batch normalization in here, and the last data is meaningful, like the middle one. Okay? Because, yes, for example, if we have your data like this one, and so we have 1 and 1 and 1 data in here, signal 3, signal 2, and signal 1. Okay? What's the biggest signal in here? Signal 1. Signal 1 is the dominant data. And so if you look at the signal 3, it's kind of the noise or the something like that, right? Because it's around the 0. But in your classification problem or the regression problem, maybe it's the what is the important part of your projects. Okay? For example, this data shows the price of your oil price. But this data, for example, is in the form of the 0.01 kilometer for the for 100 kilometers, right? Or the liter. And so this is the meaningful in our case, because if we have this deviation in here, and then we can estimate our consumption for a 100 kilometer in car. Okay? But if I use this data and our neural network diminish or remove this part, because it's kind of the noise, right? There's no effect or no impression or the improvement effect on the output. But in reality, it's important, right? And so if I use the batch normalization, and then I can normalize the whole data into one form. Okay? This is why we need to use the batch normalization at each layer. For a second example, just remember that we have the two data in here. y output 1 1 0 0 1. This is a classification problem. For example, if we have that the price is the 1 million, 2 million and 3 million. This is always a big number, but this the age. For example, your age 20, 21 or 30. And so this price is much bigger this age. And if you train your network, this age can be considered as a noise because it's small. Okay? The Bayes normalization prevents this effect to the what on your convolutional neural network application. Do you understand that right now? Okay? Each layer. You randomly put each layer. Okay? But in every case, they may not prevent these values because if you have the image, and so if you want to create the normalized data or the grayscale data, this data always between the 0 to 1 value. And so this Bayes normalization layer may or may not increase your performance. This is an optimization problem. Ensemble learning should be applied, okay? And so at every case, this Bayes normalization produced more better results. We cannot say that, okay? We cannot say that this Bayes normalization may increase your performance at every case, okay? They can or cannot. We don't know. We need to optimize that. Yes. In neural network or in AI application, we always try. There is no absolute stability or there is no absolute truth. Okay? You need to optimize that. Learn from the future at every time, like the human. Okay? Also, we have here the dropout layer. Dropout layer means that, for example, if we have the neurons with the output of the another neurons, like this one, and so 0.01, 0.2, 0.001, and 0.5. And so, if we set the dropout function or the parameters in here, like this one, or we can put the 0.1 threshold in here, this connection is removed, and this connection is removed because we know that these outputs cannot highly affect the output results because it's small. And dropout layer is used to what? To eliminate this kind of connections in your patterns. Okay? And we should know also the flatten layer. Flatten layer means that 2D to 1D conversion. If we have the 2D dimension or 3D dimension in the input of the convolutional neural network, and then we have the 2D tensor, okay? But we need to feed the neural network or fully connected layer as a 1D dimensional data, because the x1, x2, and x3 should be fed into this data as in the one-dimensional form, right? Because it's not a 2D dimension. We cannot proceed the whole this data in 2D dimension. This flattened layer utilized to what? To apply these forms. Okay? Any question? Yes? Okay. For example, you have this data structure. Okay? Firstly, this is the output layer. Okay? This is the 0.9, 0.8, and 0.001. Okay? This is the output of the hidden layers. And so, You know that in the matrix multiplication, we have the some coefficients, but these coefficients produce the what 0.9 value at the output, 0.8 value at the output. But one of them is produced to what 0.0001. This highly small value with respect to the another one. And so this is the unnecessary effort for your application. And you may cut this connection to proceed or to speed up your project or your neural network application, because we don't have any meaningful data, because it's around the zero values. Okay, and so this is the dropout layer should be used to what? To cut this connection or to remove this effect values. This could be maybe a noise value in here, and this is not important. And dropout is utilized to what? To suppress the whole this kind of data in here. Okay? Okay. And so, any question? Okay. Huh? Now that's it. In the next lesson we will talk about it. Okay? And so let's take a 10 minutes break, and then we will continue with